We are now going to talk about scope in JavaScript. This is one of the most important topics in JavaScript. So make sure that you take all the notes because everything we discuss here is going to haunt you, or rather, everything we discuss here is going to be needed in everything else we're going to learn and haunt you, of course, if you don't understand it. To understand scope specifically, scope, what it does is that it determines where variables and functions are visible or accessible in your code. So, okay, I'll just type it here. Just this one, it's too long. So basically, it determines where variables and functions need an end here, where variables and functions are visible and accessible in your code. This is the most important thing to understand because it's going to affect every other aspect of your program. And in JavaScript, scopes are what you refer to as lexical. So basically, what you mean is that it determines, or rather, it is determined by where you write your code. Scope is determined by where you write your code, right? So not by, let's say, how you call your functions. I hope this makes sense. In JavaScript, scope is lexical. Basically, it is determined by where you write your code and not how you write your functions. That is very, very important because in other programming languages like Python and the likes, that is usually the case, but in JavaScript it's a little bit different. So think of scope as the set of rules that govern how visible your variables are going to be within your code. And when you say that it is lexical, lexical is simply the same as saying static. This kind of scope is where when you have functions, you can have functions that are inside of another other functions, which is a concept we refer to as nesting. Basically, you have blocks that are written inside of other blocks, and we're going to see how this looks like. But let's understand there are two major types of scopes that we usually talk about. These global scopes and these local scopes. But local are going to basically explain that in, or rather divide it in multiple ways. Let's talk about global scope first. When you talk about global scope, what you mean in this case is that the variables are declared outside any function and outside any block of code that exists in your code. They're basically available everywhere. What that looks like is I can go ahead and declare a variable here. I can call this variable name and I can just give it simply give it my name. When I give this variable my name, in this case, this variable is not confined in any scope. It's not confined within any block, or rather, not any scope but block. It's not confined in any block or any function. So it is available globally. This can be accessed everywhere. So if I have such a variable, then I write a function here. And let's say I create a function, I call this function show name. And this function is going to just console.log the name there. So I'll just console.log name like that. Then I'll call the function show name. Again, text in no parameters, so just call it like that. And if I go ahead and run my code here, so I'll just say node, I call this file scope.js. And as you can see, when I run this, I get the output of the name here, Bonaventure. This is what we mean by global scope. This can be accessed within any function, any block that exists in the program because it's not confined to a specific block. It is available globally. Apart from global scope, there's also what we refer to as function scope, right? So these are now the more local scopes here. So function scope, just as the term states in itself, this is whereby each function that you create, each of those functions create their own scope. So variables are declared inside of these functions and they're local to that function. An example is I'm going to create a function here and I'll just call this function foo, and I'll have this function inside of this function rather. I'm going to declare a variable here. I'll just define this variable and I'll call this variable something like, let's say, secret, right? And then I'll give it a number like 45. then I'll have it print out this secret. So I'll just say console.log secret. So when I do this, this is accessible within here. But let's first of all call the function. So I'm going to call the function foo like that. And what you expect here, of course, is you expect it to print out the secret, right? Let's run it. As you can see, it prints out the secret, which is to be expected. But what happens if we try to access the secret outside of the block here? Remember, the block is, like you mentioned in the beginning, blocks are represented by these curly braces. So I can try to just console.log it outside here. So let's try to console.log it outside of the function. So outside of the function block. If we run the code here now, you will see that we get an error. And this error says we have a reference error, and the reference error is that secret is not defined. The reason it's telling us that secret is not defined, yet we defined it, is because we are trying to access it outside of its scope, right? This, because we defined it inside the function, it can only be accessible within the function. So it is function scoped. So when you try to access it outside here, we don't get anything because it's not available globally. The only variable can be accessed outside here is the variable that is available globally. Now that we understand function scope, the other part I want us to understand is what it refers. These are again still types of local scope. So I want us to talk about what we refer to as a block scope. Now, a block scope is what this was introduced later on in ES6 when the let keyword and everything was introduced. But the let keyword in itself and the const keyword are the one that introduce what we refer to as block scope. So, what you mean by block scope is that anything that is basically enclosed in this in curly braces that creates a scope. So anything that you have in curly braces creates its own scope. An example is I'm going to create an if statement and I won't have any condition. I'll just pass in a boolean true. Then I have a curly brace there. So that has already created a block, right? So that block is a scope. And if I define a variable in here, so let's say I define a variable called x, and I'll just have it say a statement like, let's say inside block, right? Just to, you know, okay, block. So this is our x there. Then we can try and console.log, but let's try create another one. So I'll use const, then I'll declare another variable called y, and I'll have a statement like, let's say, also inside, like that. So we have this if statement like this. If we try to access x and y, but you try to access them outside of that block, let's do that. So I'll just say console.log x and y. If I try to access them outside of that block and we run our program, you will notice that we also get a reference error, and it says x is not defined. The same goes for y. They're not defined. The reason for this is because we're trying to access them outside of their block, which creates the reference error. So what you need to do here basically is just move the console inside here to fix that, and then we need to just, okay, I need to move this and align it perfectly there. So now if we run our code again, as you can see, we get the statement that we wanted it to get there. But this is what we refer to as a block scope. It's very, very important to understand these scopes. Now, the thing about programming, of course, that you have already noticed up to this point is that all of these concepts always marry each other. Basically what you mean is that you can have an if statement instead of a function, you can have another function instead of another function, so they end up basically intertwining through. And even if that is the case, the entire aspect of scoping still does apply in those cases, right? So you might find a case whereby there's a bit of complexity in terms of how the if statements and the functions have been used inside each other and everything, which might create a lot of that confusion. But the other thing we need to understand when we talk about scopes is the keywords that we use to declare our variables, right? So there's the var keyword, which you talked about when you are starting. Then there's the let keyword, and there's the const keyword, right? As we know, we explained the concept of hoisting when we are talking about these keywords. And what the var keyword does, the var keyword, if you use it inside of a function, like you said, functions get hoisted, right? So what you mean by that is that you can be able to they're taken to the top of their scope, right? So what it means is that you can try to do some reassignments if you wanted to, but hoisting does happen. But when you're using a var keyword, hoisting happens within the scope of a function. That is the main thing here. Hoisting happens within the scope of a function. When you use the let keyword, hoisting happens within the block, the scope of a block. So this is that is simply it. The same thing happens for the const keyword. Hoisting happens within within the block, the scope of their block. So that is the difference between var, let, and const. Again, we don't use var anymore because of the whole thing with hoisting, but because again, get raised to the top of their scope with the functions and everything, which means you can try and access them before they're declared, and they won't raise an error as much as you'll get an output of undefined. Again, feel free to refer back to the first videos we looked at to just remind yourself of this. So this is what we mean when we talk about the entire concept of hoisting. But I'm going to try and create something here. So let's say we declare a variable with var, just to try and explain it even further. And I'll have a variable, let's say call a there, and I'll have another one b, then I'll assign it a value of 2, like that. So when you talk about the var keyword and its hoisting and everything, I can just go ahead and say console.log, and I can try to access A and B before they are declared, right? Remember, code in JavaScript gets executed synchronously. What that means is that it executes one line after the other. So it will execute line 30 before 31, then 31, 32, like that. It doesn't sort of go back and forth, right? So in that case, when you try to access A and B, we're trying to access them before they're even available. So in that case, if we're using we have the var keyword here and we have the let keyword. We're going to get two different answers here. The var keyword will just return undefined, then let is going to return a reference error. And that is the difference between the two. So if we run our code here, you will see here we have A and B, and you can see it tells us that it cannot access B before initialization. The reason for this is because with the let keyword is it's block scoped, right? So you can only access everything within a block or after it has been declared. But with var keyword and the hosting that happens, it gets moved to the top of their scope. So that is the hoisting behavior of this all these concepts here. Apart from this, the other concept you need to understand, apart from just this hoisting aspect of it, is what we usually refer to as the temporal dead zone, right? I'll just have it here. So the temporal dead zone. And the temporal dead zone, these are temporal dead zone for the let and the const, right? What you mean by this is, let me try to have a block there. Then instead of this block, I'll try to console.log a variable c, right? Again, we don't have this variable yet. Then I'll go ahead and declare c. So I'll just say const c, and then initialize it and give it a value like let's say 3 there. And I'll comment this out to avoid any errors again. Then when we run our code here, you see we still get an error, and then the error still tells us that we cannot be able to access, we're going to be able to access C before initialization. So in this case, what the temporal dead zone does is that it helps describe to us the what you have as I want you to think of it as like a period between when you're using the let keyword, which you've seen here. When you're using the let keyword, or you're using this the const and using it in a variable. So the period between when this is declared and when it is initialized with a value, right? So in this case, this is declaring. When you just say const c or let c, that is declaring. Then initializing that is giving it a value is when you now assign this value. Remember, you can do this separately. You can just say const c like that. Then go ahead here and say c is 3 there, and then you can go ahead and try and do something like this. Just separate the two to understand what you mean here. So temporal dead zone is, it helps us describe the period between when you use the let and const variable, when you declare it, and when you initialize it with a value. So this is what we mean by initialization. So I believe that breaking down has helped you understand what this means. And when you do that, during the time when you do this, if you try to access a variable, it's going to always give you a reference error, like the one that we've seen here. The reason it gives us a reference error is because we have not declared the variable yet, right? So the variable is not yet not really declared, but it's not available for you to use. The variable is not available for you to use at that time. So when you use const and the const and the let keyword in your variables, when you're declaring them, if they're not initialized before the declaration line is reached, it's going to always reach to that error. But that is simply how you can be able to fully understand what a temporal dead zone does. So if I go ahead and now, this was before initialization, and then after initialization, I can try and access C here. The difference between these two is that when I try to access it the first time here, this is gives the reference error that it cannot access C before initialization, right? So in that case, the temporal dead zone ends here because X, in this case, our value C or the X that we had before has been initialized. Then when you have line 38, here now we're able to get the output that you want. The reason why we have a temporal dead zone is because it is like a safety mechanism. A temporal dead zone is like a safety mechanism in JavaScript that helps us prevent any unexpected behaviors or any bugs that could happen when you're using variables that have not been initialized yet. So it just helps create some sort of strictness. So it just enforces the strictness, and it gives us a predictable way to try and handle the variables that we're working with, and when we try to basically initialize them. But that is on the temporal dead zone. Now that you understand the temporal dead zone, there are a few other things to understand here. There's the scope chain of a program that we work with, and the lexical environment that we've talked about. So simply, the things about the scope chain and lexical environment that we need to understand is that when you try and reference a variable, I'll just use the example of the function that we have earlier on here. When you try to reference a variable, JavaScript is going to look at three things and in three stages. It will first of all look at the current scope, right? So what is the scope of that variable? If it is global or function or block, then it's also going to try and check its parent scope, right? For example, in a case where we have a function scope here, the parent scope of this function is the global scope, right? And like you stated, you'll have cases whereby you even have an if statement instead of a function, which means the function scope is the parent scope of a block scope, right? So if you take something like this here, I'll just copy it and paste it inside here. If you have something like this, in this case, this block scope, its parent scope is the function scope, and the parent scope of the function scope is going to be the global scope. So it basically follows up like that. Start with the current scope. In this case, let's say this is the current scope, this current scope of this variable. Then it looks at its parent scope and then goes ahead and looks at the global scope. And that is the stages that it goes through. But each function that you try to invoke, it's going to create a lexical environment object, and then the environment is going to hold its own variables and a reference to its outer environment where that function of course is declared, that sort of scope. So that is basically it, and by now we understand hoisting, and we also understand the scoping aspect of this. These are some of the most important, if not the most important, concepts to understand, to help you also understand how variables move and how different pieces move when you're working with functions and when you're writing your code. So the few best practices is to always, when you're declaring your variables, try to use the const keyword by default, and also use the let keyword only when you need to be able to reassign variable, just as we stated when we talked about variables, and then just don't use the var keyword. So that is basically it on scoping. Go ahead and try to look at the programs that you've been writing. Try and just write some comments. What is the scoping of everything that I've been doing so far? And that's going to be it. This video is long enough. I'll see you on the next one.